Hello guys, very good evening. Can you guys hear me? Let me know in the chat. Can you guys hear me? Very good evening, Arad. What about others? Others can hear me? Navneet, Niranjan, Sasan. Can you guys hear me? Very good evening, Niranjan. How was your weekend, guys? Very good evening, Navneet. How was your weekend, guys? And how was your Monday as well? Did you guys practice some of the questions which we have talked in the last class? We have started, I remember, with the understanding about the hashing strategies, and then we also tried to implement the hash table with the help of arrays, and we solved some of the problems also. I remember we in the last class we were solving third problem, that was regarding the sum of there was, I think, we have to finding out that we have given one array, and yes, so we have to find out any sub array, that sum should be equal to k. Yes, that's right, Joseph. So that was the question we were trying to solve it in our last class. Very good evening, Hariharan. So we'll again look into the logic of that question in today's class as well, and then we will continue our journey from there only. So we will be solving some more questions, and then we will be starting our today's topic as well, which is the heap. Okay, guys. So let's I think let's wait for one or two more minutes, and then we can start our today's session. So I hope you guys have practiced it in the big weekends or today morning as well. Like whole day was here. So I'm expecting you guys have practiced like implementation of hash table, right? Oh, very nice, Ekta. Very nice. She has done all 5 questions from the deck. Very nice, very nice. Very good evening, Ashwin. Okay, so first we'll today look again into the logic part of that third question, and then we'll look into the coding as well very quickly. Yeah. And then we will go for the fourth and fifth question from our slide. Okay, guys. So with that, so let's start. I think we have almost all the people. So we can start now. Okay. So let me share my screen, guys. Are you guys able to see my screen? Let me know in the chat. Okay. Thank you, Arad. Yeah, so this was the third question, right? We have been given an array of integers, nums, and a value k. And they were asking us to find the total number of continuous subarrays whose sum equal to k. Correct? So they have been given us one integers array, and in that array, we need to find the continuous subarrays. Like if we have 1 2 3 in the second example 1 2 3, so you guys are already aware of there could be 1 as a subarray, 2 as a subarray, 3 as a subarray, then 1 2 can be one subarray, 2 3 can be one subarray, and then 1 2 3 can be one subarray. So you need to add all those subarrays in any of subarrays if the length is if the sum of those subarrays are coming as 3. So you need to find out the maximum length. you need to find out the maximum length there. Correct. So whatever the maximum length is there, you need to return there. Whatever the maximum subarray you got, which can be the sum of that maximum subarray could be equal to value k. That was the question they were asking to us. Correct. And then we were trying to understand the logic with this question, right? We have taken this many numbers and then we were trying to solve these questions. Correct. But before moving that, did you guys understood the question? Suraj says knows. Okay, so Suraj, say let's see. This is our. Let's first understand the question quickly. Huh? So just understand the question with 1, 2, 3. Okay, this is one sub array is given to us. Let's create the sub array for that. So sub array for this that would be 1, 2, 3, 1, comma 2, 2, comma 3, right? And 1, comma 2, comma 3. They should be continuous and they should maintain the order. That's the sub array. Correct. Now they are saying they have given one more input to us, which is k is equal to, let's see, k is equal to 3. So they have given one input to us to k is equal to. In this, all these sub arrays, they want us to find out how many sub arrays are there which can give us the sum as 3. Which can give us the sum as 3. Acha, they are not asking here about the length. Okay, we are given the nums and value k find the number of continuous. Yeah, they are saying total number of continuous arrays. Sorry guys, they are not asking about the length. They are not asking about the maximum length you need to provide us. According to that, answer would be, I think, 2, because yeah, 1 comma 2 is 3. But they are asking us the total number of continuous subarrays whose sum equal to k. So they're just simply asking about the how many total numbers of subarrays are here whose sum is equal to 3. So you can see 3 is here. This is the first subarray, which will give us sum as a 3, and then there is one more subarray 1 comma 2. This will also give us a sum as a 3. So that's why answer would be here 2. These are the two number of total subarrays which are giving us sum as a 3. That was the question actually. Some people also ask, like in the same question, they will also ask, give me the length of that maximum subarray. Sometimes you will see the questions like that. Okay, so now you got it, right? Everyone got the question now? Can we move forward? Yeah. So, okay. So before going to that, I was in last class, I was explaining you one logic that was with one straight line. Correct? I was saying if this straight line distance is y, just consider this is total y distance. Correct? If this total distance is y, this type question asked in main reliable exam. Okay. That's good, right? Yeah, this type of questions can be asked in many places, not in the main reliable exam. Okay, so guys, what I was saying. So if this is the if you got a total distance of a line which is start from A to B, if you got the total distance of it, and if somebody is saying to you, you also have one point between this line, like C, which have a distance y minus k. This is distance y minus k. So guys, if somebody is providing you this point also, so can't we say that the remaining distance from C to B would be k? Would be k. Can't we say that? If somebody is providing you a point in this line and he's saying the distance from starting to this point is y minus k, if he's saying the distance from starting point A to point C is y minus k, can't we say that the remaining distance would be k? With a simple math, y minus k plus k will be equal to y. So that's why this will become whole y. Correct, guys? Are we good with this logic? The line part? Just consider, like if this, just give it a number also. So like if this whole distance is at 20, I'm giving these variables some number. So if whole distance is 20 and somebody is saying at a point C this distance is 15. So you can automatically calculate the remaining part of this line would be 5 kilometers. If we are saying this is kilometer, if somebody is giving you two things, two inputs, 20 and 15, so you can simply calculate the remaining distance as a 5 kilometer. Correct, guys? Same logic we are going to apply in this question also. So what we'll do, we will start our journey from here. We will start our journey from here. We will say this is y. We will say this is y. As we will continuously move further, we will be saying these all are y's. Like I am just randomly moving this arrow to here. Correct. So this all points will come into y only. So like if you will add all of these things like 3, 9, -2, 4 and 1, if you will add all these five numbers, so we'll get what, like let's add it. 9, 3, 12, -2, 10, 14 and 15. So you can consider we got a line which is, let's draw it here only, we got a line which is 15 kilometer. Correct till here, right guys? I have added correctly, right? So we got the 15 kilometer lines. So now what I'm saying, I got one number, k is equal to 5. So if somehow, if I can get 15 minus 5 is equal to 10, if in this line, if I can somehow can reach to the point 10, if in this line, if this is whole line 15 kilometer, if somehow, if I can reach to the point 10 here, let's draw the correctly. If somehow I can reach to the point 10 kilometer here, which is a C point, so I can easily say that after this point, it would be 5 kilometer. If I say this is the 10, so I can simply say that this the remaining would be a 5 kilometer. Correct or not? Correct. So that's what, guys, it's happening here also. So what we are doing when we are traversing this array, we are simply keeping track of these points, keeping track of all the sums. Like first we are here, what's the total sum? We have traveled only 3 kilometers. Now okay, let's move further. What right now we are at the second point. How much we have already traveled? 12. Then we'll go here. How much we totally traveled? 10. How much we totally traveled? 14. How much we totally traveled till here? It's 15. So now you can see, once I am in 15, I am checking for 15 minus 5. Is 10 exist in the previous anywhere? Anywhere, whatever we traveled at each point, you can consider this as a point. A, B, C, D, and we are right now at E. So right now, any between all of these points, anywhere 10, anywhere we have got the 10. Yes, it was here. It was here because some here we have traveled 3 kilometers. Here we have traveled 12. Here we have traveled 10. So we can say after this point till the destination, we can see the 5 kilometers should come. So that's why you can see 4 1 will make a 5 here. Got it, guys? So that's what we were doing in our code also. We were trying to keep all these sum in a map. We were trying to keep all these sum in a map with a value like 3, 9, like 12, then 10 with a one value, and then 14, then 15. And every time whenever we are traversing, we were also checking this part, sum minus k. This part 15 minus 5, sum minus k. If sum minus k exists in the map, we'll say that after this point there will be a chances for having a k, having a value of k. If sum minus k we got it, it means after that point there are a chances for getting a k. That was the logic, guys. That was the total logic which we were trying to do in last class. Now let me go to the code part and let me show you the same thing there. So once we receive anywhere those situations where we are getting some minus k exist in the map, we'll say that this would be one of our array. So we'll simply take one count variable. We'll simply increment it. Once ever we are getting some minus k is equal to some minus k exists in the map, we'll say that this could be one answer. So that's what we are going to see in the code also quickly. how we will be indexes. So here, first thing, they are not asking about the give me the array. They are only asking about the total count. So that's why we in this particular question we do not need to take care of the length or indexes here. But yes, if in the some of the problems, if they are asking you to print out also those sub-arrays, then I think we need to while mapping it out, we need to keep somewhere the indexes, or we need to create a window which will be tracking of starting and ending positions. Understood, Likit? In this question, they are not asking about it. So this is little bit easier than the remaining questions where they will ask you to print out those arrays or those sub arrays. Correct? So let's quickly see the code here for the third question. So you can see this is the count variable which we are taking just for our answer. Like how many times we are seeing those situations where sum minus k exists in the map. Correct? Then we have taken one map here. Correct? Then you can see we are starting our sum plus is equal to num size. So we are just simply adding all the numbers one by one. And then we are checking if sum minus k exists in the map, just increase our count. Just increase our count. And if sum in, this is the like simple map setting part. Set the value of sum in map. You guys already know that. This is the object. Like we are not using a map here. You can see like the JavaScript map. JavaScript has map. Yeah, JavaScript map like new map. We are simply using the objects. So that's why we are following this strategy. If that element exists in the map, increment it. If not exist, just assign it as a one. And at the end, return a count. Sir, line number 23 needed. Line number 23. Map 0 is equal to 1. So we are just assigning first value sum 0 because see, we are starting our sum as a 0. We are starting our sum as a 0. So we are seeing that we are saying that if anywhere you got sum as a 0, you should consider it as a 1. The default value we are giving it. I use a normal hash map, sir. Yeah, no issue, Ekta. Normal hash map and object both are same. They have just little differences, but here they will work. Definitely they will work. Both hash map and object definitely work. Line number 30. Line number 30. Yeah. So Joseph, this line is simply in JavaScript they have given an in method. Like not like you can simply uh, this is like this. This line is working like this. If map sum 100. This line is like this. You are checking if sum, the value which is coming into the sum exists in the our object or not. Exists in an object or not. So if it doesn't exist, it will go into the else part. So for writing the same thing, we can write it like this also. For only for the object, we can write like this as well. Sum in map. So these are just the syntax differences. But the purpose of that line is you are checking the sum exists in the map or in the object or not. That's what happened there. Okay, guys. So this question we have already discussed in the last class, but I just want to because in the last class we were stuck. I was stuck at one point in while explaining this logic to you. So that's why I actually gone through this question again. Now let's jump into the next question, guys. Okay. Are we good with this question, guys? Already discussed in the last class. Just want to give you one more time the vision of that. Yeah. Okay. So let's move into the next question, guys. Okay. So now we got the next question where they are asking finding longest substring without repeating characters. So they have given you one string and here they are asking about the length. Find out the longest substring without repeating characters. Correct, guys? So what is the question they are asking? Let me draw that. Let's take the first example only, which they have mentioned here. By the way, I have another example also, which we will take later. Yeah. So let's see that this question. A, B, C, A, B, C, A, B, C, B, B. This is the one string which they have given us. And they are asking us, given input string as, find out the longest substring without repeating character. So two things here: longest substring, one thing, and they are saying that longest substring should not have any repeating characters. Okay, guys. So first thing they are saying we should have one longest substring, and then second thing they are saying we should not have any repeating characters there. Okay, so let's see what they're asking. So let's start from here, from the A. Let's start from A. So let's see how much longer substring it could create without repeating a character. So A, yes, itself is a substring. So length is 1 here. Length is 1. And again, guys, they are asking about the length, not the string. They are asking about the length, not the string. So length is 1 here. Okay. Now let's take AB. This is the second substring where yes, they are the longest one compared to the previous one, and also there is no character or repeating. So we can say right now the longest substring which we got, the length is 2. Correct. Let's take this thing also. ABC. Yes, in this next substring, we can see it is the longest and there is no character repeating. So we can say length is 3. Correct? We can say the length is 3. Now let's take further. ABCA. So guys, now we can say in this substring, which is ABCA, you can see it's the longest, but character are repeating. Character are repeating. So what we need to do next, guys? What we need to do next, guys? Now we got to know that in the if we are considering a as a first window, you can see this is also creating one window, right? A small window. First we have created this as a window like this. Then we created a b as a window. Then we created ABC as a window. Then we created ABCA as a window. So now you know that we are creating a window. So now when we got one repeated character, what is the next step we need to do? You guys tell me. Pop it out. That's also correct. But just we need to increase our window. We need to increase our window to right side. Correct? From the starting point. We need to increase our window. See, okay. Let me just remove these things. 1 minute. A is here, B is here, and C is here, and A is here, B is here. So guys, if I am taking this A in any of my substring, like what, like if I am increasing the length of here, will I be get any of the substring which is not repeating? After this scenario, after ABCA, if I increase my string length, am I going to get any of the substring which is not repeating? Because A is already there. After that, whatever we will take, it will always we will get the repeating characters. Even even if I say A B C A D E F G H, if I'm considering it from here, you can see all of them are unique now. But if I'm considering them from here, I will always get A as a I will always get A as a repeated character. So somehow I have to increase my window from the left side. I have to increase my window from the left side. So that's what we are going to do that, guys, here. Once we reach, so what we'll do first, we'll take 2 pointers. So we can say first pointer is the left, and the pointer which are moving, we can say it says right. So now you can say left is here right now, right is here. You can see this is a window. Correct, guys? Left and right, you guys understood? So right, left in starting, both have started from the same point. But now we are checking every time A, B, C, they are unique. So now right is here. Once we got that, no, A and A are matching. So we will be, what we will doing? We will be increasing our left pointer. We will be increasing our left pointer. So now this left pointer will be pointing out to B, pointing out to B. So left will be here. So now we compare the length. BCA, it's again 3. So we will not change this. We will not change it. So now we'll increase the right. Now we'll increase the right. So now right will be here. Again you can see, again it is like repeating characters. What we'll do? We'll again increase our left side. Again we will compare the length. CAB, again it's 3, no matter. Now let's again increase your right one. Again you got the CC, again the same length. Again first it is repeating, so just increase your it to here. Now you will again compare the length ABC. It's again 3. Nothing matter. So let's go a little bit further. Oh, let's keep it here. Let's go for this one. We got the B. It's again repeating. It's again repeating. So we'll be coming here. You will see again. Oh, it's again repeating. So let's go a little bit further. C. Correct? So that's how, guys, you will be continuously moving your left and right pointer and get the window. And you know, guys, how we are getting these length? We are getting these length with the help of left and right pointer. So wherever our, so just consider indexes 0, 1, 2, 3, 4, 5, 6, and 7. So you can see in starting, left will also be here and right will also be here. Correct? So now if we just consider this substring, so the length would be right minus left plus 1. You can see right is also at 0, left is also at 0. 0 minus 0 plus 1, it will give us a 1. So this is the one element. Now let's increase your right to little more here. Again, you can see what is the right here? Right is 1. What is left here? It's still on 0. So 1 minus 0 plus 1 will give us 2. So now you can see these two strings are going to give us length as a 2. Understood, guys? Length part we have understood. How we are going to move our pointers, that's also we have understood. Now one thing is missing there, and that is how we will getting to know, like once we reach to this place, how we will be getting that A is repeating. How we will be getting that A is repeating. See, guys, are we good with finding out the length? Are we good with the finding out the length part? Are we good with the like how we are moving the pointers left and right? Only the one thing is missing right now, which is how to find that element is repeating. So for that, we are going to use our hash map, or you can consider it as a object, hash map or object, anything you can take. You know. So okay, before moving into, let's take it. Let's take it. One more thing actually I want to tell you, but let's first start it. Okay, so let's take one object here. Correct? So let's start our traversing from the starting again. So we are at this place. Correct? So now first we will check, is A exist in our map? No, it doesn't. So let's include it and keep your pointer as a 1. Keep your pointer as a 1. Correct? Now let's go further. Let's move our right to here, B. Right? Again, let's check. B exists here? No, B does not exist. Include it. Same for C. C does not exist. Include it. And till now our length is 3. Till now our length is 3. And our pointer would be here. Correct, guys? Are we good till now? In our object, there would be 3 things. And there would be length as a 3, and our pointer would be at these places. Are we good here, guys? 2 minus 0 plus 1 would be giving us 3. So length you can see the pointers also. Are we good? Any questions till now? No? So let's move further. So once we move our right pointer to A, we will increase the value. And once we increase the value, what we'll do, we will be coming out of this loop. See, simply you can understand, until we are not seeing any of the value as 2, we will simply acquire everything. So you can see, first A was 1, we will be acquiring it. Once the B was 1, we will simply acquiring it. Once the C was 1, we'll simply acquiring it. But now A has become 2. So now we have to release this A, because this A is going to repeat it. Correct? See, the question is unique character. Every time in your map, you should only have unique characters. But as you got the character as a value as a 2, it means that is going to be problem. So you have to release something. And from which side you will release? You will release from the left side. You will release from the left side. So what you will do? You will start moving your left pointer. So first in the left pointer, you will check what is the first element you are getting. A, reduce this value. Reduce this value. So now you will reduce this value to 1 again. You will reduce this value to 1 again. And your left will be moved to B here. Correct? You will again considering the length. We are good. We'll again move further. We'll again move from here to B. Again, B will become 2. Correct? We will become again 2. You will again go back to left. And again make this B as a 1 and increase your left to here. Correct? Now you will move again. This one here. Again C will become 2. You will again move your left pointer here and you will make a C as a 1. Are you guys getting it? What's happening with the help of map? With the help of map, we are just simply we are not deleting, we are decrementing the value. Why? With the help of right pointer, we are incrementing the value. With the help of left pointer, we are decrementing the values. Because those values are creating a problem. Because those values are repeating. Decrementing counter. Decrementing counter, we are decrementing the values. You know, these values. Values of A, values of B, values of C. Wherever the pointer L left is, we are decrementing those values. Okay. Okay, guys. So that's how you will just simply design a solution. Correct? That's how you will do that. But let me show you one more scenario here, which is A. I have the example for that. A, B, C, A, B, C, D, and BA. With the same logic. With the same logic, let's try this one also. Let's try to solve this one as well. So we'll start from left, start from right. We'll take empty object here. We'll take empty object here. Correct. We'll take a length variable here and start it. So first thing, right is at A. A exists in the map, nothing exists. So A is equal to 1. So right pointer is incrementing. Right pointer will go here. Correct. Now, again, incrementing your B here. Correct. Because it's not repeating. Now let's go for C. Right is here. It's not repeating. How we are getting to know it is not repeating? Because the value of C is 1. How we are able to understand the which character is not repeating? With the value of that character in map. With the value of that character in map. Correct. So as we are seeing, C is 1. So it means it's not repeating. Now we'll go for A. And we have incremented the value. And it become 2. So now we will see A is repeating. Correct. Now we'll say, and yeah, in meanwhile, length we can also consider. So length is till now, when R will be here. By the way, 1 minute guys, when R is here, let's go back a little bit. One more step, go back to consider the length as well. So when R is here, we will also calculate the length. So right minus left plus 1. So right is 2 and left is at 0 plus 1 will become 3. So right now our length is 3. Correct? Are we good guys till now? Till now everything is unique. There is no repeating characters. We have also calculated the length. Now we will move further. We'll move our right pointer to next element, which is here. We'll increment the value of A in our map. You can see the pattern. Everything is happening in pattern. Now it becomes a duplicate. It's become a repeated character. So what we need to do? We have to increase our left pointer. Okay, we'll do that. So before incrementing our left pointer, just check the value of that pointer in the map. So it's A. So we'll decrement it. We'll decrement it to 1. correct? And now left will come here. Again, we'll check the length. It's 3, correct? Because this point is 3 minus 1 plus 1, length would be 3. Is it looking good, guys? This particular step is also looking good. If B is repeated, first not S. If V is repeated, first not A. If B is repeated first. If B is repeated first. Yeah, still we'll reduce the value of A. First we'll reduce the value of A. Then we'll reduce the value of B. Like B will be 2. Then we'll reduce the value of B. Understood? Just we'll reduce the value of A. Wherever left pointer is, we will first reduce that value. Then we'll go for the next character. We'll go for the next character. Okay. Correct. Now guys, let's move our right pointer again. Let's move our right pointer again. Now A has become again 2. Correct. This is, are we good now? Are we good here, guys? A has again become 2. A has again become 2, right? Because the next character is A. So now, guys, there is the problem. They like we can do that. That's not the point. We have to now move our left pointer. We have to move our left pointer. So first, we'll move our left pointer to here. We'll make C as a 0. We'll move again. Again, you can see A is still 2. So we'll move again left pointer to here. And then it will make our A as a 1. Correct? And then we'll move our left again to this place. Correct? This we have to do, right? Correct? This we have to do. And at this place, we will be reaching at this element. Left and right, both will be at same place. Yes, B. Oh yeah, B will also be 0. Correct. Because we started from the B. That's right. Correct, guys? That's what we did. So guys, here I am telling you one more way to do the same thing. One more way to do the same thing, which is as we know that guys, we were here, right? We were left was here, and I think right was here. Right, guys? This was the scenario. Correct? This was the scenario, guys. This was the scenario. So now what we need to do, guys, in these scenarios, what we need to do, as we know that whatever element has become 2, we know that we should know how this R has how this element has become 2, because somehow there was earlier one element of it which is right now in the window. Right now, like see, if this is our window, right? This is our window. So how this A has become 2? It means there are definitely in the current window of us, there are definitely already one A exists. Am I right or not, guys? If some elements in my window is becoming 2, it means definitely there are in my current there is one element which is already present. So what I'm going to do, guys, rather than moving one by one pointer, I will directly move to the previous position of that element plus 1. Previous position of, because see, at the end, left has to reach here. So I'm not saying it has to be like the same element every time. It's not like, I'm not saying left and right will always be at the same place. I'm saying wherever the element which has become 2, or the element which has become repeated, wherever the previous position of that element is, do the +1. See, just let me tell you again. If this A exists at this place, if this A exists at this place, so definitely we need to move this pointer after the A. We have to move this pointer to here. Am I right, guys, or not? Definitely we have to move our L to here. Am I right or not? Correct, guys? So you can understand the logic here. Whenever we are seeing any of the repeated character, we need to find the previous position of that element and then do the +1. Then do the +1 for our left pointer. Left pointer will always be the previous element, previous position of that element +1. Can you see that or not? It will reduce your steps. Earlier, what you were doing, you were traversing one by one everything. If this is a long string like this, A, B, C, D, E, A. If you are here and you're left it here, right? Uh, just make your A at this place. AE. So now, guys, you want your left pointer directly at this place, not one by one. Not otherwise, you have to traverse one by one. First traverse C, then D, then A, then you have to go. Then you can go for E. Are you understood, guys? Why we are moving our left pointer directly to the previous position of that element +1? Are we good with that or not? Yes, everyone understood? Yes, like yes, we are directly moving our window to that. And why we are doing that? Because that particular that's the previous that particular element, the previous position of that is not making your window a unique window. So that's why you need to shift your window directly to the previous position of that element +1 to the next place of that. That's why you move your window to the next place of that. So that's what, guys, that's what we are going to do in our code. So let's do that. Let's move our, so let's first dry run it, then we'll go into there. And here, we're not going to keep the counters now. Here we are going to keep the indexes now. That will tell us the previous position. That's what the one change we are going to do in the logic, guys. In our map, we are not going to keep the counters now. We are going to keep the pointers now. We are going to keep the indexes now, which will tell us the previous position of that. Let's move our question to the previous one. A, B, what is the question? C, A, B, C, D. Yeah, B, C, D, B, A. Correct? So let's start it. Let's start this question from starting again. And just keep in your mind, we'll keep the previous position of that. So now, again, left will start from here, right will start from here. So for A, it does not exist in the map. So keep it, and this time keep the position of it, which is a 0. So right now, right now, A is coming at the 0th position. It will help us once we got the duplicate character of A, we'll directly move our left to this value +1. This value +1. That's what. Let's move our R2 further. Let's move our R2 here. R is this red one. So B, keep the position of B, which is 1. Okay, we are good. It's not repeated. Let's look for C. It's also not exist. So we will keep the position of this also, 0, 1 and 2. Correct? Now, guys, we got the first A, which is repeated. Correct? Which already exists here. So what we'll do, we'll move our left to the position which we have for A +1. So now this will be moving to this index. And now we'll update the value of A. We'll update the value of A with this position, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now the current position of A is 3, which is just tracking the positions now of elements here. So now you can see BCA is there. Now let's move our A pointer again. Now our A pointer is here. Again, we see that it's again repeating. So what is the current position, guys? That's what, see, directly now we will move to +1, which is 4th position. Now we'll directly move our left pointer to here. Left and right both at the same place. And we'll update this to 4. Correct, guys? Did you guys understood? C2 how? Okay, got it. Yeah. Correct. The position plus 1. Now let's move further, guys. Now let's move further. So now our window is only one element. Now let's move further. We will move our right. So right will be here. We'll see. B exists. Yes, B exists. But this time, guys, one more thing. This time, repeat index part, lost network. Which part actually you're saying? The moving part? Joseph, see, whatever value we have here for that element, we just need to do plus 1 and move our left pointer. Whatever value for the whatever character is repeating, just take the value of that plus 1. And at that place, you need to keep your pointer. And that's why we did for left as well. You can see earlier left was at the 1 position. Correct? Here at the B, at the element of B. But as we see that the duplicate character of A has come and the last value of A was 3, so we directly updated it to 3 plus 1. That's why A is here. Understood? That's why A is here. That's why the left pointer is at this A position. Now guys, next point. Once you see that B is, you got the B here, and which that B already exists. But you have to check here one more thing. The position which B is telling, is it coming under your window range or not? The position, the value of B, which is coming, see, first thing you are checking B exists in the map or not. Yes, it exists. Second thing you need to check, the value of B exists between your left or right range or not. Exists between your left or right range or not. This time the value of B is 1, which does not exist between your left and right window. So that's why you will not do any of the things. You will simply update the value of B. You will simply update the value of B, make it 5 and calculate the length. That's what you need to do. Let's move further right. Move it to C. Again, C, you will again see the position of C is 2, which is not between your range, which is not between your range. Update it. Update it. Update this C to 6. Whatever the current position of 6, C is 6. Now let's move further. Now let's move further. Make it right here. Now D does not exist. So take the position of D, which is 7. And you can see, guys, the length is here 7 minus 4 plus 1, which is 4. 7 minus 4 plus 1, which is going to be total as a 4. You can see total length is 4 going to be here. Okay, we are good. Let's move for B again. Let's move for B. Now, guys, you will see that B is at 5th, which is coming inside the range. Right now, you can see left and right range is 5. It means there is a problem. So now what you need to do? Guys, tell me what you need to do. Where I need to move our left pointer? Where I need to move our left pointer, guys? Just see here. Where I need to move to our left pointer? Guys, can you see that? Where we need to move our left pointer? Because B is, the value of B is coming between our range. What happened, guys? Are you guys not able to understand? Anyone wants to respond? We need to move left. Yes, 6th index. Correct. So we'll directly move our left pointer to the value of B plus 1. The value of B plus 1. And it will be moved to this place. Correct? It will be moved to this place. So now again we'll calculate the length, which does not matter, and we'll move our right to the next element. Left and right. Now we'll see that A exists in the map. Yes, A exists, but the position of A is not between our range. So what we'll do? We'll simply update the A's value, make the 9. And this is the total length. Again, 4 already exists in the answer 4. That's what, guys. Two things you need to find it. Two things you need to check. One, if any element which is repeating exists in the map, it means it's repeating. You need to take the last position plus one for our left pointer. You have to move our left pointer to that position. You are reducing your window from the left side. And second condition is here, when you are seeing any of the letter which is repeating or means exists in the map, you need to check the value of that. Does the value is coming between the ranges or not? If it is coming between the ranges, you need to do the next step, which is the take the previous element plus one. If it is not coming between the ranges, then simply update the value of that character and do not do anything. Understood, guys? Just two things you need to think. Got it? Everyone? Arad, Vishal, Joseph. Anyone has any doubt with the logic part? I will wait for you guys to ask any queries if you have. Then we'll jump into the code. Code is also very easy. Yes, what is your doubt, Arad? We need to move left. Why? This one. If duplicate come in the ranges. Okay, so if duplicate come in the ranges, so for duplicate scenarios, by the way, they are saying about the contiguous array. So let's see that the queries question. Let's see that they are accepting duplicate scenarios. Given an input string as find the largest substring without duplicate. What was that again? What was the query? Duplicate come in the ranges. If duplicate come in the ranges, you mean like if something is coming in the ranges? I mean, yeah, if it is coming in the window, then you need to do take the previous element plus one. Take the value of that element plus one for your left pointer. If the element is in the window, if your element is in the range or in the window, so you just need to take that element plus one for your left pointer, because that particular element is going to create a problem. That particular element is going to make your substring as a repeated string. You see, this B or C, who was that? Yeah, this B was coming into the window, right? Earlier B was here. Earlier your pointer of left was here, I think, at this position. I remember, yeah, it was here. And now you can see B comes into the picture, right? So now once the B coming and you have checked the value of B, you have checked the value of B and you find it out that B exists in the range. So what you did, you move your left pointer to here at the C position. You moved your left pointer to C. Now this is your window. Because if you will keep the B in your substring, you will never get any unique string. That's why you are moving the pointer to the last element wherever you found plus one. And then you will update this B to 8 for the next element. Understood? Yeah. Everyone, Hariharan, Suraj, you guys got it? Yeah. So let's see the code, guys, quickly. Code is very easy. See, guys, first we have taken the left, right, length, map, and the total string length. And then we are running our loop. Then we are simply running our loop. While right is less than n. Means while right is less than n. So this right will continuously traverse till the whole length of a string. Correct? And then we are simply checking if the right exists in the map. It means if any of the duplicate character exists in the map, what we need to do? We have to move our last index. First, we'll get that element from the map. You can see, we'll get that element from the map and then we will add it. Last index plus one, comma left. Last index plus one, comma left. Which one is greater? We'll assign that to left. So this one is automatically checking the range part as well. If your left is not coming between the ranges, then automatically you will not change your left value. So see, earlier scenario, when the left was here and your B was coming as a 1, when your left was, just consider this scenario, when your left was here and your B value was 1, B value was 1. So you will not change the left. You will not change the left. You do not need to do 1 plus 1 because already your B is out of range. So that will you will take the same value of L. That's what happening here. We are just considering which one is greater, last index plus 1 or the left value. So if last index plus 1 is greater, it will only happen when you are in the range. It will only happen when you are in the range. If it's not, then you will take the left only. And for the right, you are just simply updating the value of right every time. And then here you are considering the length, right minus left plus 1 comma length, whatever the length you are assigning earlier. And then at the end you are doing right plus plus, and at the end you are returning your answer as a length, whatever length after traversing whole loop, whatever length is coming, that will be your answer. Very easy questions, very easy logic as well. Correct, guys? Anywhere you guys find difficulty while understanding the code, whatever we explained, that's what we did. You can see here we are considering, here we are updating left value every time we are checking if it is between the range or outside of the range. This is automatically happening here. We are fetching the last index from the map and then we are comparing it, last index plus 1 comma left. Right now wherever left is, which one is max, I will update that as a left here, and then simply updating every time the value of right. And then we are every iteration we are also calculating the right minus left plus 1, which will give us the length. Y max. Yeah, so get us the maximum value between those two. Joseph, if your B is here, which will give us, the index is 1. So 1 plus 1 will give us 2. So where I need to keep my left? Here or here? So which is telling us that left should be here. So that's why I'm taking between 2 comma 5, which is max. So 5, it means I have to keep my left here only. I need to keep my left here because this B is out of range. That's why when I'm doing plus 1, it is giving us the lesser value. Otherwise, if you take here, if you're considering about this scenario, if your B is 5, so we'll do there 5 plus 1 comma 6, and your left is still at 5, so 6 comma 5. So you need to move your B now. So your now left will become 6 at this place. This is the scenario. That's why you are doing the math.max. Take the maximum values. A max value will always be you will get if you are in the range or outside the range. Okay, got it, Joseph? The reason for that, let's run the code. Let's see which example we are taking. A B C A B C D B A. Yeah, I think same example we are taking. So let's run it. So node as stable problems 4.js. Yes, our answer is 4. Okay, guys, got it? Code was not tough, right? Code was very easy. Just 4 to 5 lines. Yes? Yes, practice is definitely required. But you understood the logic. Now the practice is not required. You do not need to write the code in this way. You can write code according to yours way as well. You know that you have to check the range every time. You have to check two conditions every time. If that element exists in the whatever element right now, wherever your right pointer is, if that element exists in the map, you need to take 2 actions. First, you need to check the value of that element which exists in the right, is it coming between the range or not? Range is left to right. If it is coming between that, the second condition you need to check. Second condition you need to use, like if there is no second condition, if it is coming between the range, then you need to do take the value +1, move your left pointer there. If it is not coming between the range, leave the left. Wherever left is right now, keep it there. These are two conditions. Okay, guys. So you just remember these two conditions for these questions. You can implement your own logic. No need to copy it. Yes, definitely we can write without maps as well. Totally agree, Ekta. I think you have used what? Arrays? With the arrays also we can do, or what else you used? First string one, no sir. First string one. Yeah, first string one I was saying, yes. Which data structure you have used for solving this problem? Oh, dot includes. That will include the complexity n square. That will increase the complexity. Arrays will be good. No, Joseph. With the arrays, you will increase the complexities, time complexities. With here, I think you are just doing one traversal. It's O of n. But array dot includes will definitely do the n square. But yes, space complexity is here O of n as well because you are using a map. So space complexity is also O of n. Okay. Yeah. So let's jump into the next question, guys. Let's jump into the next one. Next one is also similar to that. Yeah. So the question is, given an unsorted array of integers. So first thing, they have given an unsorted array. And they are saying that find out the length of the consecutive subsequence of an array. Find out the length of consecutive subsequence of an array. By the way, they are asking about the length, but in the output you can see they are also printing out the elements. We can do both things. They are just simply asking about the length. Let's understand the question first. So they have given one unsorted array. So let's type the first array, which is 100, 4, 200, 1, 3, 2. This is an unsorted array. And they are saying you have to find out the consecutive subsequence of an array. So consecutive subsequence of array, it means if we can simply sort it, because consecutive means, what is the meaning of consecutives here? The consecutive means is like there should be like consecutive means the difference between two elements should be one, like 1, 2, 3, 4. Those are consecutives, right? So that's what here if you see in the examples. So the consecutive array or subsequence of array, because why they are saying subsequence, it should also maintain the order. It should also maintain the order. That's why they have sent the subsequence. So you can see here the consecutive subsequence is 1, 2, 3, 4 only. 1, 2, 3, 4. You can see they are consecutive also and they are subsequence also. They are also maintaining the order. 100 and 200, they are not consecutive. In the second example, you can see 0, 3, 7, 2, 5, 8, 4, 6, 0, 1. Apart from that, the consecutive subsequence is 0, 1, 2, 3, 4, 5, 6, 7, 8. Correct? So that's what you can see here as well. If we can simply sort this array, let's just sort this array. 1, 2, 3, 4, 100 and 200. You can see, guys, automatically subsequence you got it. Because in subsequence, everything will be in sorted order. So you can see 1, 2, 3, and the 1, 2, 3, 4 is also consecutive. So that's why our answer will be here 1, 2, 3, 4. Same goes for second question also. Let's take the second question as well. 0, 3, 7, 2, 5, 8, 4, 6, 0, and 1. Correct? If we can simply sort this one as well. 0, 0, 1, 2, 3, 4, 5, 6, 7, and 8. This is the, after sorting, this looks like this. But you can see 0, 0, they are not consecutive. I told you, right? There will be two elements consecutive when the difference between them is 1. So difference between 0 and 0 is not 1. So that's why it will start from here, and you can see all of the elements which are like each other, like 3, 2, difference is 1, 4, 3, 1, 5, 4, 1. So answer is this one only. And they're asking about the length. You can give the length or whole elements, anything. So that's what the question is, guys. You have given one unsorted array. So simple, I think if you can sort it simply and then check it out, like start from the first element and then check it out, what like how many elements are coming continuously. Like if we start from the zero, and if we start from this element zero, after sorting, if we start from here and then we check the next element should be 0 plus 1. If it is, then it will start from here. If not, let's take the next element. Let's take the next element. We'll start from here. Again, we'll do plus 1. This one, no. Again, we are not. If yes, it is 0 plus 1 is equal to 1. We'll go for this one. 1 plus 1 is equal to 2. So, like the next element, check, like go, iterate it and just take the next element. If it is plus 1, then just include this one. And then at the end, just return your output. Wherever you find out the same values, just return it. Did you guys getting what I'm saying here? Even for dot has in maps is a time complexity O of n. For has in maps, time complexity O of n. Dot has. No, it's O of 1. O of 1. Because just remember like the previous class, how we will search element in the hash table. We will first encrypt the key, and then directly once you will encrypt the key, once you will get the hash value for that, you will simply find out the array position. Once you find out the array positions, it would be O of 1. Yeah. At one go we find its O of n would be for array. For finding out any element, it would be O of n. Yeah. At one go we find. So now first we will sort it. In this question, first we will sort it, and then we can simply find it out the plus 1 part. Correct. But no, guys. But let's see, guys. We'll do with other way, because see, with the sorting, it will make this n log n complexity. It will automatically increase n log n. It will automatically give you the complexity. Correct. And then I think n log n would be maximum there. N log n you will get. Is there any other way we can do it? So yes, there is one more way which we are going to try it without sorting it this array. Without sorting it this array, we are going to try one more way. Let me show you that. Okay, without sorting this array, we are trying to do one more way. Okay, so what we are going to do, guys, we are going to use one map here. Okay, so just take one map here, or object, whatever you want to say. Okay, see, guys, as we know that for becoming a consecutive number, as we know that okay, 1 minute. Yeah, for becoming a consecutive number, that number should be minimum, and after that there should be all the greater numbers. Like if I show you, like 1 minute, guys. Okay, in this question, just try to find out in this array. Just first try to find out how many how many elements can come as a first element. Like, I think this example is not good. Let me take any other example if I had. Let me check if I have any other example. 1 minute, guys. For this question, let me check if I had any other example for fifth question. Okay, this one. That's fine. I think it's the same, right? Okay, that's fine. Let's start from this one only. Not a problem. So see, guys, for becoming a consecutive, which is in the sequence. So how will it happen? As we have seen the answer, there would be 1, then 2, then 3, then 4, then 5, then 6, then 7. Correct? That's what the consecutive numbers are. Right, guys? So definitely, whenever we are making any list of consecutive numbers, there would be a one number who is going to be first. Who is going to be first? Like in this case, one is going to be first. In this case, one is going to be first. Why not two? Why not two is going to be first? Because in this array, one already exists. One already exists. So so see, if I'm traversing any of this array, and if I want to find out like what are the numbers which can be first here, what are the number which can be first here, how will I try to find out? How will I try to find out which are the number which could be first here? Because see, in this particular array, there if I specifically talk about this particular array, you can see there how many subsequence can be started here. So first subsequence is 1 comma 2 comma 3 comma 4, then 100, there is no other number, then 200. Can you see that there are three number which can become the first number in sequence? Correct? There is three numbers which can become the first for any of the sequence. So how will I find out this? Just try to think about how we will find out in this whole array which are the number which is going to be first. Vishal has said correctly, for searching for the numbers next. If I find it out, for any of the number, if any previous number exists, like for the case of 4, if 3 exists, it means 4 cannot be first. Correct? For the 4, if I find it out somehow, 3 exists, it means 4 cannot be first. Is it true or not? If anyhow, if I find it out, any of the minimum number exists, it means that particular number cannot be first. Everyone agree with that? See, 3 could be first. Let me know why. Why 3 cannot be first? Why 3 cannot be first element? Guys, just see this array. Why 3 cannot be first element? Yes, because there is a 2. Yes, because there is a 1. Correct? So that's why we are going to start traversing an array. So we are going to look for -1 and +1. Why we are looking for +1? Why we are looking for the +1? So I will tell you why we are looking for the first one. In this array, let's include some more element actually. Let's include some more element. Let's take the example from here. Yeah, 102, 4, 100, and then take 101 also. This 102, 100, then take the 3, then 101, then 2, and then 1. Correct? Let's take this one. So let's start from the first one, guys. Let's start from the first one. Let's start from the 102. Can 102 be the first? Can 102 be the first? Yes, because right now our map is empty. Right now our map is empty. So we'll say yes, 102 as a true. Yes, it could be first because our map is empty right now. We cannot understand. Correct? So that's why, yes, Joseph, if one is there, we'll go into that element. But right now, we are at the first element. We are here. Till now, we do not have anything in the map. So we'll say that, yes, 102 can be true. It could be the first element. Okay. Let's move further. Let's move for 4. So just check in the map. 4 minus 1, 3 exists in the map? No. Check for 4 plus 1. 5 exists in the map? No. No, right? So that's why let's keep 4 as a true also. That yes, 4 can also be true. So you are checking for two things. -1 plus 1. If they both exist, then we will see. Then we'll see. Okay. Now let's go further. Now let's go for 100. So now what we need to check? What we need to check? 99 and 101. Correct? 99 and 101. So yes, just check. 99, 101 exists? No. 100 can be true. Till now, guys, if I have, just think about, if I have this much array only. So we will get three subsequences, right? 4, 100 and 102. Three separate subsequences. Correct? If we have only this much question in this much array in our question, we will be seeing three different three different subsequences. Okay, but now we will have we have more elements here. So let's traverse little bit further. Let's traverse little bit further. Now we'll go for 4. Now we'll go for 3. So what we'll check, guys? What will check, guys? 2 and 4 exist or not? 2 and 4 exist. If 2 exists in the map, will 3 will be the first? If 2 exists in the map, will 3 be the first? If 2 exists in the map, will 3 be the first? No, right? So that's why 2 does not exist. So 3 still can be the first. Correct? 3 still can be the first because in the map 2 does not exist. Check in the map, guys, not in the array. In the map 2 does not exist. It means 3 still can be the first. Correct? You guys understood, guys, why 3 is true right now? Everyone understood why 3 is true right now? Okay, now let's look for 4. 4 exists in the 4 exists in the map. Yes, but we have find it out. 3 already exists in the map. So it means 4 no longer can be the first. 4 no longer can be a first. So we'll change this to false. That's why we are checking for +1 and -1. For +1, we'll make it is false. And if -1 exists, we'll make the current element as a false. If -1 exists, if somehow 2 exists, we'll make 3 as a false. We'll make 3 as a false. That's why we are checking minus and +1. Okay. Now let's move further, guys. Everyone understood why we make 4 as a false? Everyone understood why we make 4 as a false? And let me show you in the code also, guys. The same thing is happening there also. You can see the same. We are passing an array. We are checking the array. We are checking map.has array I -1. If that's the case, make the array of I as a false. Else make that as a true. Then also check for array I +1. If array I +1 exists, make it as a false. Did you guys understood this much code? 17 to 26. Same thing. Whatever we are doing, same thing happening here. If -1 exists, make the current element to false. You can see current element is becoming false. If -1 does not exist, make the current element as a true. Then again check for +1 also. If +1 exists, make the +1 to false. Understood, everyone? Let's go back to further to our code. Let's look for 101 now. So first check, 100 exists? Yes, 100 exists. What we need to do now, guys? If a -1 exists, what we need to do now? Make the current element as a false. Make the current element as a false. So 101 will become false. Automatically 101 will become false. Correct? Now we'll check for +1. Now we'll check for +1. So 102. 102 exists? Yes. Make it also false. Because this can no longer be a first element. Correct? Let's do for next element. Let's go for 2. So first check for -1, which is 1. 1 exists in here? No, 1 does not exist. So make 2 as a true. 3 exists? Yes, make 3 as a false. Make 3 as a false. Correct? Now let's go for 1. Check for 0. 0 exists? No. So make 1 as a true. Check 2 exists? Yes. Make 2 as a false. Guys, can you guys see that this map? Have you guys understood this map? Don't we make 100 as a false? Why? Do we have 99 there in this array? Do we have 99 in the array? Joseph, do we have 99 in the array, Joseph? But greater than true. No, no, no. We are checking for -1 +1. Wherever whatever index right now we are just checking for -1 and +1. We are not checking for more than that. Okay, so that's why you can see, guys, we got two numbers here which can be the first element, which is the 100 and the 1. We got the 2, and that's true. You can see 1 2 3 4 can be one sequence, and 100 101 and 102 can be one sequence. That's why you can see 1 and 100 as a first element. Correct? Correct, guys? So this map is totally correct. Got it? So now when we have this map, what we need to do, it's very easy, guys. Just traverse the key of this. Just start traversing this particular map, and wherever you got the true, take that element, like you got the true at 100, so consider this as a because we are talking about the length as well, so just take the length as a 0 here, and come take this element in the like one of the array, like current element is equal to 100, correct? And then start a loop here, so just when you got the 100, let's do the 100 plus 1, which is 101. It does it exist in the array? Yes, it exists. Increase your length to 1. Increase your length to, increase your length to, let's take the length as a 1 because 100 already exists, right? So length is 1. So let's now increase it to 2 because 101 also exists. Again, do the same thing. 101 plus 1. 102 exists? Yes, it exists. Increase your length to 3. Let's look for 102 plus 1, 103. 103 exists? No. Just quit this loop. Come out of this loop. And then you can see length is 3, current element is 100. You can see 101, 102, 103. This is one of the subsequence. Then again, look for next true element, which is 1. So again, 1, length is equal to 1. Again, current element is equal to 1. Correct? Do the same. 1 plus 1. 2 exists? Yes, it exists. Increase the length. Again, 2 plus 1 is equal to 3. 3 exists? Yes, it exists. Increase the length. Make it 3. 3 plus 1. 4 exists? Yes, 4 exists. Increase the length. Make it 4. 4 plus 1. 5 exists? No, 5 does not exist. Just come out of this loop, and at the end, return this as the answer. Length is equal to 4. If they are asking about the length. If they're not asking about the length, if they are asking the current element, so just take this current element, which is 1, and run the loop for 4 times, and every time do plus 1. So 1, 2, 3, 4. You will get the element as well. Because you have the current element, you have the 2 pointers there. So that's what happening in the code as well, guys. Very easy. Once you got that array, just take two variables here. Max length is equal to -1. Max starting number is equal to 0. Start traversing into the map keys. This is the map.keys method, which will give you the key. Now you can see wherever you got the key as a true, assign that key as a starting number, which I am taking it as a current here. You will see this current, it will take the key, count as a 0. I'm continuously checking for current starting number plus count. So we'll continuously increasing one by one, one by one. If that exists, I will continuously do that. And at the end, once that element does not exist, I will come out of this loop, and I'm checking if my count is greater than maximum length, assign it. And then at the end, push. If they are asking about the length, you can simply return the max length as your answer. If they're asking about the element, you can just loop into the max length, and whatever the starting number is, this particular element is, Just do the plus I into that, and at the end you will get your answer. So that, yeah, that was the just difference. We are finding two sequences here. Yeah, we found two sequences here in this example, and the longest length was 1 2 3 4. So that would be our answer. The longest length we need to find out. So 1 2 3 4 was the answer. Two continuous subsequences. Got it, guys? This was also very easy question actually. Just the logic was there. We can get many sequences. Yes, you can see in this earlier example, when we have 200, when we have like 400, we can get many sequences, but we need to find out the longest one. We need to find out the longest one. Yes, if 100 would be yes. If in the same example, if in the same example, 103 also exists or 104 also exists, so yes, 100 would be the greater answer. If both are same, like both are same, I think any one of them can be answer. If 100 is also 4 and 1 is also 4, so I think anyone can be the answer. Okay, guys. So that's all about the last question. Let's start looking into the today's slide, heaps, and the next topic. There also we will having the two assignments problem. So let's look into them as well. Oh, you guys want to go for break? Okay, so let's take a 15-minute break and let's come back at 9:40. Okay, let's come back at 9:40. Is everyone back? Hariharan is back. What about others? We'll wait for one more minute and then we will start. Suraj is also back. So let's share my screen. You guys able to see my screen, right? Yes. So yes, so we are going to start our heaps and easy problems. So before that, there are two assignment question also there. So I will be covering the first assignment question because in the second assignment questions, there are some errors which are mentioned in the code which they mentioned, and the query is also wrong actually. So I will talk with the relevant team for the question two, and the assignment question two, the solution which they provided, that's not using at all um, uh, the the map. They're using the arrays there. So I will talk with them, and if they are not able to find it, I will try to find out the solution for that problem, and then we'll discuss about the second problem. But let's discuss the first problem. And with the first problem, you will learn one more thing in the JavaScript, that's called set. Okay, let's first read the first problem. With the help of set, this problem we can easily solve it. So let's read it. So you are given two integers array 1 and array 2. Populate an array that includes the intersection of array 1 and array 2. Correct? So you can see, and they're also saying in the resultant array, every element should appear as many times as it is present in both the arrays, including the duplicate elements. So like if you see here, where is that? Yeah, see here, this one, 1 2 2 1 and 2 2. You can see 2 is coming two times, it means duplicate elements. So you have to print, you can see in the both arrays 2 is coming two times. So you can see the answer also they have printed 2 as two times. Same goes here, 4 9 5, and here you can see 9 4 4 4. So 4 is coming one time both arrays, so you can see 4 is coming as one time. And then you can see 9 is also one time. See, they are saying how many time it is coming in nums1, same time it has to come into nums2. Then only you need to print that as the answer. Otherwise, you need to print it as a 1. So you just need to simply print the intersection of it. Yes, 4 is coming two times, but it should come two times in both arrays. It is coming 4 at a first one time in the first array. You can see 4 is coming at the first time, one time only in the first array. Understood? So it is coming in the both arrays. So you know, like in the mathematics, we have if we have given two sets, we can easily do the unions, we can easily do the intersections, right? Yes, the common elements between those two. Correct? That's what the intersection is all about. So everyone understood the question? Intersection it sets, yes, Navneet, correct? Yes. So see guys, before that, let's understand the set. So there is one like same map. We have the map here, array here. Similar, JavaScript also provides set. You know, in the set, the set has very specific property, which is lot of functions are set are equal to map functions like add, get, has, size. These all are the method which map has, similar set also has. But set has very specific property that set always has unique element, always keeps the unique element. Let me show you. Let's open it. No, no, no. Let's open it. Yeah. So let's first take an array. Let array is equal to 1, comma 2, comma 3, comma 4, comma 5, comma 6. Correct? We have this array. If we can simply print it. Correct? In similar way, we can have the set also. So let's set is equal to new set. Correct? And if we just want to pass out the same array, we can pass out that as well. Hmm. I should change the name. It is not taking that as a name, no? S is fine. Let's print the S. It is just taking the whole. Yes, you can see it is coming like this. 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, comma 6. You can see. So set works similar like this. You can see, but it is coming in the curly braces. Set has their own methods like s dot get, and you have to pass the value of that. 1 minute. S dot get is not the method. 1 minute. S dot add is a method. Sorry. S dot add is a method. Like you can add 7 in the same set. You can see. Now you can add the 7 there. But the why I'm telling you this, the difference between set is set can have a set will always have a unique element. So let me show you that also. So let's create a second array with some duplicate elements. 1, comma 2, comma 2, comma 3, comma 4, comma 4, comma 5, comma 6, comma 7. Let's create the duplicate as 7 as well. Correct? Now we can see our array 2. You can see all the duplicate elements are here. But somehow we only want unique elements. We don't want any duplicate elements. What we'll do, we'll create a set here. So let S2 is equal to new set. And we'll pass our array 2. Now, if I show you S2, you guys will be seeing all the unique elements. You see, 1, 2, 3, 4, 5, 6, 7. Not any duplicate elements. That's the important property of a set, guys. It always keep a unique element. And sometimes you have the requirements when you are getting any duplicate data from the UI side or somewhere, but you just want to keep the unique data. So it will just simply delete it. That's the property a set has. Yes, no duplicates there. And if you want to read about more about that set, you can simply search set in JavaScript and you will see that. It has a lot of like methods. Get method is also there. Set method is also there. Add method is also there. Get method is not there, I think. It is the properties they have for the constructor function. The methods they have these things. Add, clear. Clear means everything will be clear from the set. You can delete any of the values. Has, you can check the values. Same, you have the iterators like the map. You see, these are the methods. You can add it here. You can check that exists or not. You can delete it. You can find out the size and all those things you can do with the set as well, which you can do with the maps. That's what. Now this particular thing is going to help us to solve our intersection problem. To solve our intersection problem. How? Let me tell you. And let me show you, by the way. So let's take the second array, 495, or the first one. Let's take the first one. And let's create the set for that, which is 1, 2. What is the first array? 1, 2, 2, comma 1. Let's create the set for this. So this set will look like 1, comma 2. Correct? Correct, guys? The set will look like 1, comma 2. Now, just simply traverse. What was the second array? What was the second array? 2, comma 2. 2, comma 2. Now, for this, you just need to simply traverse this array and check that if that element exists in the set. So you will just simply check 2 exists in the exist here. Yes, print it out or insert it. Second 2 exists. Yes, it exists. print out. That would be your answer. Same, check the other examples also. 495, 495 and 94984. Just take any of the arrays in set, any of the arrays. So let's just take this one. So 4, 9, 5. These are the unique one. So just start traversing from here. Just start traversing from here. So you can see here. So 9 exists. No, for this problem, I think 1 minute. Mm, see, we can't take any one of them, right? I think we should be taking the maximum length actually. When you take this one, then actually, yes, 94984. Yeah, we need to check this one. Or by the way, you know what we can do next thing? No, yeah, just take this one. So 4984. But yeah, I think actually we need to decide which one we need to take. Because if we will take this one, if you will not take this one, then I think we are going to get the duplicate answers, right? So you can see if I am taking 495 only, 495 in my set, then actually we are going to get the duplicate answer. See, 9 exists, yes, 9 will be printed out. Again, 9 will be printed out. And 4 also will be printed out. And then 4 will be printed out. But as per the output, this is not correct. You see, as per the output, they are only submitting 4,9. So I think we should take one of them. And how we will be deciding that? That's what I'm thinking. Or we can, if we will try to create both offsets. Let's see if we try to create both offsets. So it would be 495. And let's use this one 489. Correct. So 4 comma 9, yes, from here we can get the 4 comma 9, 4 comma 9. Yes, this will solve the problem. What about this one? What about this one? 1 comma 2 comma 2 comma 1. It will give us 1 comma 2. And here it will give us 2 comma 2. It will only give us 2. So it will only give us 2 actually as an output, right? Okay. Okay, I think one thing is missing here, so let me check it. But yeah, the reason is here, guys. I want to explain you about the set, but it looks like one thing is missing here in both of the queries. Might be possible this question is again wrong. Let me check the code here if we have for the intersection. What they are doing, A1 and A2 is there. Okay, nums1, nums2 is there. Let me check, guys. What is the code they are doing? They are adding A2 first. Okay, they are adding the second array every time, and has one dot add, and then they are checking with this within the first array. Okay, let's see if we are just adding a 2 comma 2, but that still doesn't make any sense, right? Why we are taking the second array every time? So 2 is there, 1 comma 2, 2. Yeah, that will give the answer. I am fine with that. And here also it will give us the answer. But yeah, actually, see, with the logic which they have provided in the solution here, that looks like they are always taking the second array. But that will not help in every situations, right? I feel that will not help in every situation. So I will take a look into both of the questions, guys, both of these assignment question, and then we'll talk about them again. I will first talk with the team in Reliable, then we'll talk about these two queries again. But guys, did you guys have understood about the set? How the set are working here? Yeah, but this, set helps actually to find out the intersection. Let me check if there is any general code will be there. Intersection of two arrays with set. I have seen this example. Yes. Let me see. if they have anything. Let's see in the Stack Overflow quickly. They are filtering it out. That is different way. I'm trying to help with set. Yeah, this is a set intersect. Okay, new set dot filter x dot set. Yeah, that's what they are also doing, and then they are traversing the intersection. But if the somewhere like the condition might be the wrong for the intersection part, because see, one of them cannot be one of them. If we say that, like see, according to example, they are always taking the second array 2 comma 2. They have like wherever how they are deciding they have to take the second array in a set. That's not clear. Yeah, so we'll see about it. Yeah, but yeah, the important thing is here we have to see about the set part. Correct, guys? So let's move into the next topic, guys. Okay, in meanwhile, anyone have any doubt on the set? Let me know in the chat, guys. Okay, we are good with set. Let's jump into the next topic, guys, which is asked today's topic. Okay, we will see about this queries, but yeah. So let's understand there is one more new data structure exists, or I would say that the part of data structure exists that is called heap. Okay, so it's a heap. It's also a binary tree, and it's relate with almost complete binary tree. We have the almost complete binary tree. What was the properties of almost complete binary tree? The properties was all the labels except the last will be filled, and then the last level will be as much as possible from the left side, left to right. Correct? That was the almost complete binary tree. So heap is also it's similar to almost complete binary tree, but it also have one more feature. Like the BST in the binary search tree, we have one feature. What was that? All the left side child would be smaller than the parent, and all the right side element that would be equal or greater than the parent. Correct, guys? That was the BST property for the BST. Yes, in the heap also has a property. So the first thing is they are almost complete binary tree. We are talking about here binary heap. So the binary heap are they are equal to the almost complete binary tree. And second property is always the parent would be greater or smaller to the child, both childs. Always the parent node will be a smaller or will be a greater. When we are having all the parent as a greater, we call it as a max heap. We call it as a max heap. All the parent would be greater there. And when we are having a parent as a minimum, we will be saying it as a min heap. Okay, there are two type of heaps are known as. One is called max heap, second one is called min heap. Max heap is when we have a parent node as a greater element to their childs. When we have a parent element to greater than the child elements, and when we have a minimum element, the minimum parent, when we have a minimum parent compared to their child, it's called the minimum heap. It's a almost complete binary tree, Joseph. So two properties you need to remember about the min heap. But before that, why we require min heap? Why we require these heap? See, guys, always heap helps you to find out the maximum and minimum values. Okay, let's talk about the simple example. If I have given you an array, which is not sorted array, and if you find out the maximum and minimum, what would be your time complexity in that array? If you find out the maximum, or minimum, that would be O of n. Correct? That would be O of n. But what about if that array is sorted? What about if that array is sorted? How much time complexity will happen now? 1. Correct. Because in the sorted element, the maximum element would be on the right if it is increased, it would be on the right. Minimum element is the 0th index. Correct. But for sorting, minimum it takes n log n, right? The worst scenarios, it takes n log n. Correct, guys? So, but with the help of heap, we can get max and min in constant time. With the help of heap, we can get max and min in a constant time. That's what we are going to look today. How the heap, so see how the heap, because in a way we construct a heap, which helps us to keep our maximum and minimum. That's why, the properties of the heap, binary heap, which we are talking about, all the max element will always be in the parent node, and then child will always be smaller than that. That will be called max heap when we want to find out the max element. And when we want to find out the minimum element, all the root node, we will create it as a minimum element. Now let me tell you the real time application of these heaps. So the real time application is when the our operating system uses a queue. That queue is called priority queue. That queue is called priority queue. In the priority queue, we use these min and max heap strategy. These are strategies, guys. Min and max. These are strategies. So we use the min and max strategies for our OS to choose the or decide the priority of the processes. In the queue, we were talking about the priority queue also. In queue, we were talking about the priority queue also. You guys remember? So priority queue also we implement with the help of these heaps. Priority queue we also help with the priority queue also. See the in other languages we have the priority queue already implemented. They provides you min or max values. You will be like entering multiple elements into the queue. You can only delete min or max. You have to choose. You have to delete the minimum, because in the queue you delete always from the front and insert from the rear. Correct? So always the front element will be a minimum or the maximum, and that internal implementation happen with the min heap or max heap. That's the one real-time example. OS scheduler, priority queue implementation, and producer consumer wherever. And I think lot of places like sorted distance in the Dizzy or shortest path problem, we always look for maximum or minimum paths. Correct? So we use some data structures there, which is called priority queue. Internally, those are implemented with the help of min and max heap, which provides us in a lot of numbers, lot of ways, what are the minimum ways, what are the maximum ways. Those are the real-time applications of min and max. Okay, guys. Now let me show you one example of min and max tree. Okay, before that, let me put the charger. 1 minute, guys. Yeah. So as I was telling, min heap and max heap, they are just the binary trees and almost complete binary trees. So let's start it. So we are trying to create the max heap right now. So max heap, what is the property? Always the parent will be greater. Parent will be greater to their child. So let's start creating it. Like let's take 85. So parent, always the child of this would be smaller. Always the child of it would be smaller. So let's take it. Let's take it here 56. Let's take it here 57. Correct? You can see child of these elements are smaller. Let's take again. Let's 56. Let's 32. And let's take the 33. correct? Let's take here 50. We can't go greater than that. So here we can create 48. Here we can create 46. This is our max heap, guys. And you know, in the max heap, absolute complete binary tree, we can insert one more element on the left side, right? Which would be smaller than that. So like 27 and 28, correct? Right should be always greater than root. No, that's the BST. That is the BST. In heap, only the parent and child. Parent should be greater. You can see always parent is greater. 32, 33, parent is greater. This is max heap. In the min heap, it's the opposite. Parent would be smaller. So start with smaller, 10. Then go for child would be greater. So 14, 16. In the 14, so 22, 19, and it should be greater, right? So 26, 28. This is the min heap. You can see always the parent is in the minimum shape. So parent should be greater. Anything right side should be greater than left side. Is it not? No, no, no. That's not the case. That's not the case. There is no right and left scenario here. It should be parent should be greater than the child's. Understood, guys? There is no parent scenarios. Let me show you in the screen as well. Let's see here. This is the max heap. You can see the parent node has a higher value than its child node, and any parent has at most 2 nodes. It qualifies as a max heap. There is no left and right conditions. Okay, you can see in this example why this is not a correct heap, because you can see 25 and 27, so it should not be greater, because we are trying to create a max heap. So parent should always be greater, but here child is greater than the parent, which is not the case. You can see everywhere parent is greater, but here this 27 is not making 26 as a greater. So that's why this is not the max heap. This is not the heap, we can say. Understood, guys? These are some of the examples they are telling about the heap. Every parent node will have at most 2 child nodes, and the special condition is all child node must strictly be either greater or lesser than the parent. If they are greater, if the childs are greater, then it would be min heap. If the child are smaller, then that would be max heap. Are we good with understanding min and max heap, the requirement of it, why we need min and max heap? Are we good with that? How we decide priority between siblings if heap is used for priority queue? How do we decide priority between siblings if heap is used for priority queue? We always take an element which is on the right side. We always take the element which is on the right side, because we are filling it in a we are using the almost complete binary tree, correct? So we have to decide any one of them. We see, Vishal, we have to take any of them, left or right, anyone you can take, right? And then you have to, once you make it as a node, once you make it as a minimum, then you need to check. Is it going to make a min heap? Is it going to balance out min heap or max heap properties or not? Whatever you are choosing. If you are choosing left one, you have to check. Is it going to maintain a min heap or max heap property or not? That's what, Vishal, I would say for your answer. Any siblings you can take. But you need to, after choosing the sibling, You need to check, is it going to make min or max heap property or not? Where whatever min heap you are implementing, so it should it's whatever siblings you are taking, left or right, it should maintain the min heap property every time. Okay. Sir, one question. Less than equal to and greater than equal is followed, right? Less than equal to and greater than equal to is followed. For which thing? Equal is not there. Here, there is nothing for left and right ekta. Here only parent and child. For parent and child. No, no, not equal scenario. Not equal scenarios. We are just right now talking about the always the min and max. Min and max. So in the equal scenarios, I think yeah, we can consider like anywhere we can take if it is equal. See, in one of array, if the see just simply consider scenarios. You have an array, you have to find out the minimum and maximum element. So if there are duplicate element also, that's fine. There would be one maximum, right? And that maximum will be a root node for you. Max or min. Yeah. So that's how, guys, the min heap and max heap look like. Now let's try to implement them. Now let's try to implement them. And before implement them, let's try to representation of them. Okay. And we are going to use arrays only, but for implementing the heap, we are going to use the arrays only. But if you remember about the binary search tree or yeah, binary search tree, I have showed you two representation there. One with the help of class node and second with the help of arrays. Correct? The same thing we are going to do here as well. We are going to implement with the help of second approach, which was the arrays. And let me show you how. Okay. Yeah, as you can see here, this is the let me draw it there in a one node. There we will be clearly seeing it. So this is our first parent node 26, which has 25, which has 22. Correct? What else is there? So 25 has two childs, 20 and 24. What is this, guys? Min heap or max heap? What is this, guys? Min heap or max heap? It's a max. Why? Parents are always greater than the childs. You see, parents are always greater than the child. So now, if we want to simply construct an array out of it. So just simple drawing, they are saying you can write it like this: 26, then the left child first, 25, then the right child, 22, then again 25 left child, 20, then the right child, 24. So if in the array, if you want to keep it, they will look like this: 26, 25, 22, 20, and 24. And let's take write their indexes as well. Correct. So right now, if I want to find out the left sibling of 26, or anyone's left or right, we just need to do 2 times I plus 1. This will give us the left sibling. And for the right sibling, it will be 2 multiply I plus 2. Let's see that. For 26, if you want to find out the sibling, so 2 multiply 0 plus 1, it will give us the first position. You can see 25 as the first position. And for the 22, it will give it here. Now let's look for 25. Let's look for 25, which is the first index. It will give us the 20. It will give us the 24. For 22, there will not be anything. 2 into 2 plus 1. So 5 does not exist. So that's why there is no child for that. Got it, guys? From any index, we can find out their left and right child. Correct? From any index, if we want to find out the parents, from any index, if we want to find out the parent, so the formula for that would be map.floor I minus 1 by 2. Let's see this works or not. So if we want to find out the parents for 25, so let's see. So the index would be 1 minus 1 divided by 0, which will give us 0 divided by 2, correct? And which will be 0 only. The answer will be 0. Let me check, guys, 1 minute. For finding out the parents, let me check 1 minute. For finding out the parents. That formula, actually, I want to check 1 minute. So finding out the parents is not here. Okay, let me check in the code, guys. 1 minute. Why to, like, let's check quickly. For finding out the parent. Yeah, n minus 1 by 2. Yeah, correct. The formula was correct. 1 minus I minus 1 by 2. So yes, so 1 minus 1, 0. Let's find out for the 2. So 2 minus 1 divided by 2, which would be 1 by 2. Again, 0.5. And the floor value would be 0. So for 22 or for 25, parent would be 0. For 20, let's check for 20 also. 3 minus 1 divided by 2 will give us 1. So for 20, parents is 25. Let's look for 22. Let's look for 24. So 4 minus 1 divided by 2. 4 minus 1 divided by 2, which will give us 3 divided by 2, which will give us 1.5. So again, the first index. Correct? For the 3, same logic. 3 already we have checked. For the 2 already checked. For 0, there will not be any index, I think. 0 minus 1 divided by 2, it will give us minus 1 by 2, which does not have any parent. So 26 is automatically it's a parent. Correct, guys? So these are the formulas. Explain 3. 4. Index 2 multiply I plus 1. Left. Yes. So for finding out the left element of it, so this is our array, right? This is our array. 26, 25, 22, 20, 20, 24. If I'm taking any of the random index like 20, this one, 1, if I want to find the left element of it, you just need to apply this formula, 2i plus 1. So you will see 2 into 1 plus 1, which will give us 3, third index. This is the left element for 20. Same for 4. Same for the right element. So say for the same root, if you want to find out the right index, it would be 2 into I plus 2. So 2 multiplied by 2 plus 1. Sorry, 2 into 2 multiplied by 1 plus 2, which will give us 4. This is the right element, and that's what you can see in the diagram as well. Okay, guys, understood, Suraj? The left and right elements. Everyone understood left and right element? Everyone understood left and right element? So now let's insert it. Now let's insert it. Now let's start creating our min heap, min or max heap, anything you want to do that. Okay, so let's start it. So let's take an F. I represent label. Yes, I represent label, we can say. Because we are going to do insertion from the back side. And we are going to do the insertion level by level only. Yes, we are going to do the insertion level by level because it's almost complete binary tree. Always insertion will happen level by level only. Because it's almost complete binary tree, Navneet, right? So in almost complete binary tree, whenever we are inserting anything, it will always be happen level by level. Okay, so let's start. Let's start, guys, inserting elements. Yeah, let's create a new page. And let's draw, like we will drawing two places, like array at one place array. Right now array is empty, and here our tree also. Tree is also right now empty. So first insert is 18, and we are trying to create the max one. So let's insert the bigger number. Let's insert 45. Okay, we are trying to create max heap, guys. Okay, so 45. So 45 would be the first node. And we will be, because right now array is empty, so we'll be simply pushing it here as the 45. Correct? We will be simply pushing it as a 45. Correct, guys? Everyone good till now? First element, we just simply need to push it from the back side. Okay. Now let's do the second thing. Now let's do the second thing. Now let's insert the second element, which is going to be insert 36. So according to the binary tree, it should be inserted here into the left side. Correct? It should be inserted on the left side. Right? Yeah. So always, according to the logic, first you will always insert into the back. First you will always insert into the back. So guys, let's now see the process steps. Every time, whatever the steps will happen. So let's see. First time you will insert into the back. So your array will look like this. So you have inserted into the back 45 and 36. Correct? You have inserted it. Now you need to fix the position of it. Now you need to fix the position of it. So now what you will do, you will check that. You will check that whatever the new element you have created, is it the greater than the parent or lesser than the parent? Is it the greater than parent? Because we are right now checking for max heap. So it should be lesser than parent. Correct? Whatever the new element is coming, it should be lesser than element. If it's not, it should be parent then. Correct? Whatever the next element is coming, if it is the lesser than that, then insert it into the left side or into the right side, anywhere. If it is not, then make it parent. If it is not less, because we are trying to create max heap, guys. We are trying to create max heap. Always parent should be greater. So if any new element is coming, which is greater than the parent, so we have to make that element as a parent. Everyone understood that? If any new element is coming there, if that element is greater than the parent, we have to make that element as a parent. We will follow almost complete binary trees rules here. Yes. Not all the previous. That's what Ekta. We do not need to compare with all the previously added item. We just need to compare with the previous parent. We just need to compare with the parents of it. So let's find out the parent for this element. Right now, this element at this position, 0 and 1. And how we will find out the parent for that? So the formula for finding out the parent is mat.floor I minus 1 divided by 2. Just check there. Just check at that place. Because why with all the elements? With the parents only, right? Correct, Ekta? With the parents only. We'll compare it. So let's compare it. So right now, I is 1. 1 minus 1 divided by 2, which will give us 0 divided by 2. It means that the 0th element. So compare with the 0 element. Compare with the 0 element. That 0 element is greater, then it is okay. Then it is okay. If that 0th element, which is at the parent, if it is greater, then we are okay. Yeah, yeah, that's fine. That's fine. BST is little bit different. BST do the different purpose, and it does the min and max. Guys, can we understood? Can did you guys get this point? The maximum one. Parent should, because we have find it out the parent for that node. Whatever new node we have inserted, we are trying to find out the parent for that. Correct? And once we find out the parent, we are just checking parent should be greater, otherwise we will replace it. Otherwise we will replace it. Okay? Now we are good. For 45, 36, we are good. So what we'll do, we'll keep in our final array, we'll keep the 36 at the same position. No need to make any change here. Let's keep the 36 at same position. Okay? Keep the 36 at same position. Okay? Now let's insert something else. Now let's insert It should be lesser, right? So let's insert 35 or 38. Let's enter 38. So 45, 36, 38. Same logic. Same again, same logic. This will be 0, 1, 2. Parent would be 0. It's greater, then we are okay. We are not going to do anything. We are not going to do anything. Correct? We are not going to do anything. We are going to insert 38 here. And this will look like here, 38. Correct? Now let's insert 50. Now let's insert 50. Correct? So now let's find out the parents for 50. Now let's find out the parent for 50. So 45, 36, 38, comma 50. Correct? Everyone wants to know, right? Wrong. Why? What we did wrong? Can't be inserted. Why? No, we are doing it. First, see guys, always the first step, insert it from the back. Always the first step, insert it from the back. Then we'll do the, we have not checked till now. We will check it. Wait for that. We'll check it. First step is always push it. So you have pushed it. What is the index? 0, 1, 2, 3. Let's check the parent for 3. Let's check the parent for 3. So let's use the same formula. Mat.floor I minus 1 by 2. What is the parent is coming? This is the parent index, Pi. So Pi is coming, I is 3 minus 1 divided by 2. Again, mat.floor, which will give us 1. Correct? The parent index would be 1, guys. Parent index would be 1. Agree? Now we'll check, is the parent index is greater, like array of parent index, is it greater than the current element? The current element index? Is it greater? No, it's not. So what we need to do here, we will simply swap these elements. We will simply swap these elements. What we'll do, we'll simply swap these elements. So let's swap it. Let's swap it. Let's swap it. Make it as a 50, make it as a 36. Okay? Swap with parent index for an element. Yes, swap with parent index element. And now update your current index element, this current I, to the parent index. Current index to parent index. So now you will be checking for this index. Is it the, now you are going to check the same thing for this index. First, what you did? First, you have checked that is it the parent index element is greater? No, it was not. So first replace it. First you have replaced it, and then you updated the current index with parent index. Why? We are going to check, is this 50 is it correct place or not? Is this 50 is at correct place or not? So we are going to check for this index again. So we are going to do the second loop. In the same one, we are going to do second loop. So again, parent index is equal to, now I has become 1. So 1 minus 1 divided by 2, which will give us parent index as 0. Correct, guys? Which will give parent index as a 0. Yes? Again check. Again check. Is the parent index is greater? Parent index is greater than the current index? Again check. Is 45 greater than the 50? Again swap it. Again swap it. Now 50 will come here and 45 will come here. Now 45 will come here. Correct? Now again do the same thing. I is equal to Pi. Now this will become your current index, and which will go outside of it. Which does not have any parent. It does not have any parent index. So we will stop it. So we will stop it. And now you can see the 50, which is the greater element, which is here. Now the 45 will be here, the 30 will be here, and 38 will be here, and the 36 will be here. Finally, it will look like this after inserting the 50. Always at the 0th position, guys, you will find it out the maximum element. Always. That's why we are implementing min and max heap, because at the constant time, always at the array 0, you are going to get the values at the constant time. Understood, guys? The insertion part you guys have understood. Let's see the code also very quickly. So we do this swapping until the property of max heap is not restored. Yes, that's what I was answering to Vishal also. We do not care about the siblings. We do not care about the siblings. We just need to maintain the property of max or mixed min heap. And that property is always the top element has to, max element has to come at the 0th index. And once you will do the same thing, automatically every element will be at the right position. Every element will be at the right position. And you can see you are not doing an iteration here. You are not doing any iterations here. You are just simply removing a half of the tree. You are just traversing at one side. Correct? You're just traversing the root by. So let's quickly see the code for this also, guys. For the insertion. So you can see this, this is our max heap, where we are creating the heap. You can see first thing, pushing the value in the heap. That's what I told you the first step. Any new item is coming, you have to first push in the heap. That's what we did. That's what we are doing. You can see first we are pushing into the heap. Then we are checking if the heap length, after pushing it, if the heap length is 1, it means we have inserted the first element. No need to do anything because it's the first element. Simply return it from here. If it's not, if n, now we have calculated the length of heap. And then you know that what we are doing. We are first calculating the parent index. And you can see, guys, always, because we are inserting the element, always the latest element will be at the last position. That's why we are inserting it. When we inserted 50 was here, right? So always the new element will be at the last point. That's why you can see first we have find it out the parent index for that. Then we are checking if parent index is greater. If parent index is greater, do not do anything. If parent index is not greater, then swap it. And then make your current index to parent index. And then continuously run this loop. That's what we are doing. That's what we were doing. And that's what is, you can see here. I will give you 1 minute to look for this code. And then we will go for the delete scenario. Are we good, guys? Any queries in the code? Yes, it's easy actually. Are we good, guys? Anyone has any queries? Parag, Hariharan, Suraj? If array is used for trees and heaps, does that make them have linear traversing properties? Does that make them have linear traversing properties? See, array why we have used here. The reason for using array is because in the array we can simply see there are two things we can use here. One is array, second one is the linked list. Correct? These are the two core data structures which we use everywhere in stack, queue, trees. Trees has different structure, but these are the very core. So now you can implement the same logic with linked list also. But in linked list, there will be little bit difficulties to finding out the left and right. But with the arrays, because array has given us the quickly index properties where we can directly access those elements. That's why we are using the arrays here, not the linked list. Linked list will create some problems. You have to traverse every time in the linked list while inserting and while deleting as well. But here Here you can simply traverse through indexes where we can easily find out the parent index, left index, right index. We can easily do that. Correct? So that's why we are doing it. Yeah. So now, now let's look for the delete scenarios, guys. Okay. So now this was the insert scenario. Now let's look for the delete scenarios. They are explaining about the delete scenario. Okay, let's fine. That's fine. Let's now talk about the delete scenarios, guys. Okay. Let's take a max heap again. 84, 76, 78. Let's take one more element here. So we can take it because it should be smaller. So 54, 55, correct? And then we can have here 68, and we can have here 64, correct? We're doing correct, right? And then we have uh, yeah, 50, 48. Let's just take till here. Yeah, just take here. Okay, guys. So now, if we want to delete any element here, so what we need to do here, guys, for deleting any element, see, we can let me 1 minute, guys, because we have to think with the arrays also. Let's take the same in array as well. So how will this look like in arrays? 84, 76, 78, right? 54, 55, 68, and 64. Correct, guys? It will look like this in array. Correct? Yes. Yes, it will look like this in array. So now we need to delete it smartly. That 1 minute, 1 minute. Uh, hmm. 1 minute, one minute, guys. Okay, one thing I want to check here. Okay, we'll do it, and then we'll think. Then we like wherever I will start. I will just check into that. So see, guys. First thing, what we need to do here, whenever somebody is saying to us extract max, the function is extract max. Extract. The function is extract max or extract min. These would be the two functions which a heap provides. You can see in the slides as well, right? You can see extract max or insert is, we have already covered the inserted. Let's say they will say extract max or extract min. So it means they would be they want us to remove the max. Right now whatever max we have, remove that max, and then try to find out the next max into the min heap and make it as a root node. Correct, guys. Just think about it. Right now, our max is at 0th position, right? 0, 1, 2, 3, 4, 5, 6. Our max is at a 0 position. Am I right? Am I right, guys? Just check in the array. Just check in the array. The max is at the 0th position. And they are saying extract max. It means remove that max. So after removing this 84, we need to find out in the remaining array we have to find out in the remaining array what is going to be our next max. Correct? That's what we need to do. then only we will be then only we will be maintaining the heap properties. We have to find out the next max. Are we good till now? Okay, so now guys, what we are going to do, we are going to replace our max. First we'll delete it and we'll replace our max with the last element, because that element we can easily fetch it with the last element. So see, how will it look like? The first operation is just replace this element with the first element, with the zero, yeah, with the max element. So this will look like this: 54, 55, 68, and 64. Okay, replace 64 with the first element, okay. Make the last element as a root element. Okay, that's the first step we need to do. Every time, whenever somebody is saying, you have to extract the max, so your first step should be replace the last element with the max element, with the first element in the array. Okay, that's the first step. After that, guys, after swapping it out, let me check 1 minute. Yes, do we removing it also? Oh yeah, we are removing the last one. 1 minute. Yeah. So let's remove it. Yeah, delete it. Delete this one also. I was just keeping that 64, right? Just delete it. You will not keep it. Yeah. So this is the next array which we got it. Okay. 64, 76, 75, 54, 55, 68. So this will look like this. In the array, it will look like this. In our tree, it will look like this. 64 will be here. Okay, guys, this is the first step. Always remember, this is the first step going to be. Whenever somebody is saying to you, extract max, extract min, you have to first replace or swap, whatever you want to say, with the last element in the array with the top element or first element, and then delete the last element. That's what I did. And now, guys, you need to heapify it. Heapify it, or again, you need to check, is the current element, is it going to fulfill the max heap properties or not? Whatever the current element you have taken, is it going to fulfill the max heap properties or not? Okay, so that's what, guys, we are now going to look for, that is it going to follow the max properties or not, max heap properties or not. Okay, so let's start from zero, guys. We'll start from this index, and this time we are not going to look for parent element. This time we are going to look for left and right index. So for finding out the left index, what would be our code? 2 into I plus 1. For right index, our code would be 2 into I plus 2. And whichever is the maximum between these two, that will be swapped. So like you can see, for the 64, for the where I is equal to 0, when I is equal to 0, you can see the left index would be 2 into 0 plus 1, which would be 1, and right index would be 2. These two elements. Correct, guys? These two elements. Which one is greater between these two? 78. So replace 78 with 64. Replace 78 with 64. Got it, guys? Yes, we earlier we were looking for parent, but this time we are going to look for left and right index, and whichever is maximum, we will choose that one. Or if one of them is present, we'll take that one also. We'll take that index also. Okay, and now we'll update our current index to the one which we have updated. So we have updated with the right index. So just now make 2 here. Now make it 2 here. That's what happening in the code. Let me check quickly. Yeah, correct. Yeah. Whatever the highest index, just take it there. So I is equal to 2 because if we have replaced with the right index. So that's why we are taking the 2 here. Correct? So now let's move further, guys. Now let's look for I is equal to 2. Let's calculate the left index and right index for that as well. So for the I is equal to 2, the left index would be 5 and the uh, right index would be 6. So let's look for 5. 5 is there, 6 is there. 5 is there, 6 is there. Okay. Which one is greater? Which one is greater? 68. So we will replace 68 with the 64. Correct, guys? Which you can see 68 is greater. Correct? 68 is greater. So we'll replace it. Now this 68 is greater. So now the 68 will be coming here. And the 64 will be going here. Correct? And we do not have anything on the right side. We do not have anything on the right side. You can see we do not have anything on the right side. So we will be simply not going there. And we'll update our index to left index, which is 5. And now you can see we do not have like if we want to calculate a left or right index, we won't reach anywhere. So we'll stop it there. So now this will be our latest array. And you can see 78, 76, 68, 54, 55, and 64. This looks like this. You can see this array has been converted in like this. Let me represent it here. 78, 76, 68, 54, 55, and 64. Can you guys see that? Is it still maintaining the max heap properties or not? After deleting the max, it is still following the max heap properties. So that's what we are doing in the deletion also, guys. Extract max. Any step where you guys have missed it, let me know in the chat. Any step where you guys think that was a little bit tough, or should we go into the code? Let's go into the code then. Yeah. Okay, so see, if we do not have anything in the heap, simply return null because we can't delete anything. Correct? Then what was the first step? What was the first step? Replace the 0th index value with the last value. That's what happening. First, I've taken the max value, which will be at the 0th index. Then I've taken the last value, which was popping it out. And then I'm again checking if the like after popping it out, if there is nothing in the length, just simply return the max value. Because if we only have one element, so we have already popped it out. So just simply return the max value. But if this is not the case, then replace the heap 0 with the last value. And then start doing the process of finding out the left and right index. You can see left index and right index. This is the condition. This is the first condition which I am putting if it has no child. We have already seen, right? Left child if we do not have any, if it has not, if the last condition, right? Where we have seen that we do not have any left child. So in those scenarios, we are simply breaking it out. Now the next scenario, if only left child is present. There was one scenario, right? This scenario, 78, 68, because it's absolute complete binary. Left child could be possible here. So that's why we are seeing here, if only the left child is there, if only left child is present, then we will check if right index is greater than heap.length. What we are doing here, we are just simply checking that thing only. If the left index should be less than heap n, left index should be smaller than the current index. If it is, then break it. If the left index is smaller, then break it. And if not, then swap it. If the left index is greater than the current element, then swap it. If it is smaller, then keep it, and then make n is equal to left index. If both indexes are there, right and left both indexes are there, so we can see here I'm checking if left index is greater than the right index, whichever is highest. That's what I'm checking. If left index is greater than right index, take the left index, otherwise take the right index, and then swap it. And only swap it when the highest index is highest index is greater. When the highest index is greater, when the right side or left side index is greater, then only replace it, otherwise do not swap it. The same logic which we have discussed here, the same logic we are writing it here. I will give let me come back to chat and let me see anyone has any queries there. Let me open the chat like this for some minutes. And guys, after that you can see get max. I'm just simply returning this dot heap 0. Simply returning this dot heap 0. Let me increase the size. Oh, 1 minute, guys. Yeah. Anyone has any queries? Did you guys find any difficulty to understand the remove part as well? Or was it easy? We usually use arrays for heap, yes, because it will give you faster data. Can you please tell me once again from the line 56? Line 56. Line 56. So yeah, this was the swapping is happening where we got our current index and the left index. We are simply swapping it out. Correct. This is our swap function where we are simply swapping the elements. Okay. So this is the if and else conditions. If in one of the scenarios, if only left child is present, if any of the scenarios only left child is present, so we are just simply checking if right index is greater than equal to heap dot. See, first we have checked left index. If there is any left index which is already going out of heap dot length, it means definitely we are not going to check the right side. There will not be any right child, correct? But there would be chances when only left child is present. So on those scenarios, I am checking if right index is greater than equal to this dot heap dot length. Means left index exists. I'm also checking is right index also exist. So yes, if right index does not exist, it means only the left index exists. So I'm just checking there. If left index is less than heap dot n, break it. If not, swap it. If both of the indexes are there, just check that which one is greater, left or right. If left is greater, take the left one. If right is greater, take the right one. And then simply checking the condition, which one is greater? Is it the lesser than the current index? If yes, just swap it. Swap it. Once again, explain process. If condition again. Okay. So these are two conditions, guys. See, I think you guys are missing it, understanding the learn. Like I think you guys are like what, like learning the code or what? Understand from here, right? See, we are checking here. If see, first thing very easy, the else part. Once you reach to the one place like the index one, you need to check for the left and right index. Left and right index, correct? Which one is greater? You need to take which one is greater. You need to take that one, correct? So you are checking that between like for if we talk about which one, two, right? Yeah, for the I is equal to 2. Yeah, for 68 or not sure, there was the same situation. I'm not sure how it was earlier, but you know, right? If I'm here, I'm calculating the left and right, which is 4 and 5, left and right. So I'm comparing which one is greater in this. Whatever greater, just replace it with the second. So that was happening in else part. Here, find out the highest index and then check. Is it greater than the current element? If not, break it. If it is, then swap it. Understood the else part, guys? Understood the else part? Yeah. Understood the else part? Now let's look for the scenario where we have only got the this one, I think 5. Yeah, I is equal to 2, right? I is equal to 2, where we only got the last element, the left element. You can see for 68 only we have the 6 4. You see, we only have 6 4 in the absolute complete binary tree. You know that, right? The left element could be there, so only one element could be there. So that's why we are taking the first part, this thing. If how can we check, how can we check that only left child exists? We can check if right index is greater than heap dot length, means right index does not exist. So if right index does not exist, left index exists. So just check for the left index and swap it. This was the if condition. We are checking here if right index is greater than equal to heap dot, because if left index is not there, this condition is already there. The first condition, if left index is not there, if left index exists there, which is outside of the heap range, simply break it. If left index is there, then I'm checking for right index. Is right index outside of range? If yes, it means there is only one element which is on the left index. So checking it. If both are there, left and right both exist, then to go for the else part. Understood, guys? So that's what the whole code, guys. The min and max. That's this is written in the max heap. I want you guys to implement the min heap also. Right now we have implemented the max heap. You guys, can you guys implement the min heap and share me the code in LinkedIn? Small changes, right? Where right now we are looking for greater, you need to look for smaller and swap it same way. Correct? Need to check. What, Arad, you have not understood the logic part? Yes, everything will be same. Right now you are making a greater element to the first element in the array. You are making maximum element to the left. You need to go for the smaller one now. Yes, need to check for the smaller. Okay, guys. So I want everyone to implement the min heap and forward me the code in LinkedIn. Okay. Let's see. There are actually two small problems also. You know, search is there. You know, guys, where we are doing. So this process when we are doing this while loop in the insert also and in the extract max also. This process is called as heapify. This process is called as heapify. We are checking children's and replacing parent with maximum. Yes. And same we are going to do for min as well. We are checking children's and replacing parent with mixed min one as well. Okay. And this process is called, guys, heapify. The technical terms they have given. Searching is easy, right? There are two problems actually, I remember. Yeah. So they are saying given an input array of unique elements, return a max heap created out of same element, expected worst case. So I think you guys can implement it, right? The same logic will work. They have given one input array and you need to return a max heap created out of the same element. Same logic will work. You just need to run a loop into this array. You have to just run the iteration into that and insert one by one each element. And once you will inserted everything, at the end, return the this dot heap. Correct? Just they are saying that they have given one array of unique elements. You have to return the max heap. Same logic will work. In this code, you need to call this insert for each of these arrays element. Correct? So every element will take, see, this iteration will take n time and insert part will take log n. So you can see the time complexity would be n log n. Did you guys understood this thing? What I'm saying here, you need to just iterate this whole array and insert it into this class. Once you will insert it, everything will be properly inserted because we have already written the code. 90 will always be on the max, always be on the first element, then 36, then 17, and then you can just simply return this dot heap. Got it, guys? This question? Easy, right? Yes. The next question is also easy. Let me show you that one also. They have given the link also, solution link as well. So second question is, guys, they have given again you one max heap array, max heap as input, and you need to find out which is greater. You need to find out. See, yeah, they have given you two things: max heap and one number, and you have to find out that maximum number. Like, see, k is given as a third, so you have to find out the third largest element in the heap. Third largest element in the heap. Okay. So now they have given you max heap. You have to find out the third largest element in the heap. You know what to do here? Anyone can tell me? In the max heap, if somebody wants to say you have to find out the kth max element, what you will do? Kth max element. Any idea? With these two methods, you have insert, extract. Yes, Ekta is given correct. We have to remove it two times. Remove the k times. Once you will remove the k times, like, see, they are saying third max element. So first time you will do the extract max. The second max will be the second max in the array will come at the first position. Then you will do again second time do the extract. Do the third time. Third max will come at the top. Third max will come at the top. Yes. So you have to use the extract method. And let me show you the code also which they have in here. That's also doing the same thing. You see, they are first running the first loop, KCI, then whatever we did, take the max value, take the last value, first update the last value, n is equal to 0, run a loop, find out the left and right index, do the same thing, only left child is present, both child are present, then update the kth max value. And they will be continuously doing it 3 times till the k times, whatever value is the for k is. So once the kth time is ended, you will just return the value. And kth max value they have taken in the top. So just try it. It was easy. Whatever we did, we have to just follow the same. Okay, guys? So I think that's all from today's class, guys. That was the last question which we had. We have covered the min and max app. See, guys, in some way they might ask you to implement the priority queue in the interviews or somewhere. In the bigger organizations, I've seen somewhere they ask you to implement the priority queue. At that time, you need to think about these methods. The insert and extract max or extract min. They will help you there. Yes, it's a min max binary heap. Yes. It's a binary min max binary heap. And I am requesting everyone to implement the min heap as well and share the code on LinkedIn. Okay, guys? I hope you guys have enjoyed the extraction and insertion part in min heap and max heap. And you know, guys, this particular part definitely reduce the time complexity, because insertion and extraction is only taking the login. Insertion and extract part is only taking the login time. And you know, lot of questions we use the priority queue. I'm not sure why JavaScript has not provided us any default way to implement priority queue. There is no default way. Like we can implement set, map, stack, queue, but there is no default way to implement a priority queue. In Java, we have a separate class for priority queue, but in JavaScript, we don't. I will see like we have to write a code in similar way to implement the priority queue. Not sure, like there would be some intentionally they have not done it. Not sure it's their mistake. I'm not read about it, why they have not it. Priority queue did not get priority in JS. Might be because, you know, priority queue mostly is used in the OS or like CPU intensive task. like shortest time. I remember in one of the interview questions, there we have I have to use the priority queue only, because there was a lot of elements I was inserting in the queue, and I only need to find out the minimum element. Otherwise, for how to implement the priority queue here in the JavaScript, you need to every time sort the array. See, in the queue you are inserting element. So when you are inserting any element, you have to every time sort it. Then it's again the priority queue. But it takes time, right? Sorting takes n log n. See, just take one array, 1, 2, 3, 4, right? Like random, just take an empty array as a queue, and then insert 4. Then insert 1. So now you're inserting 1, right? You have to again sort it. So 1 will be, if you want to create the min heap, or your priority queue is only returning the minimum element, so you have to again sort it. Are you guys getting it what I'm trying to say here? If you want to implement the priority queue, it will be only implemented with the help of sorting. Yeah, it will only be implemented with the sorting in JavaScript. But in other language, we have a direct method, direct class for the priority queue. Okay, guys. So that's all from today. We'll meet in our next class and talk about the next things. Okay, guys. One class, you can please talk about the interview experience related to core computer science subject like OS, Hoops, etc. I will mention it to Ansul, and then we can have a separate discussion, one class where we can just simply talk about the general topics and any other interesting topics which are going on. Yeah, and you guys can also mention it to Ansul, so he can arrange one session, and we can talk about these things there as well. Yeah. Or might be in the revision class if we might get that time there, we'll talk about them. Yeah. Okay, guys. So let's wrap this class, and I'm waiting for your responses in LinkedIn where you will implement these things in the min heap. Okay. Good night, guys. Bye bye.